Okay, today we will dive into integrating the MERN stack, a powerful collection of technologies for web development. We'll learn how to build complete, dynamic, full-stack applications entirely using JavaScript. Let's explore the core technologies that make up the MERN stack, each serving a vital role. These are the essential components for creating robust and dynamic web applications. First, we have MongoDB, a popular NoSQL database. It's primarily used for efficient and scalable data storage in your applications. MongoDB offers a flexible, document-oriented structure, making it easy to manage diverse data types. Next, we have Express.js, which is a back-end web application framework. This framework runs on Node.js, providing essential tools for server-side development. It effectively handles API requests and manages the routing for your web application. Then there's React.js, a leading front-end library for user interfaces. React.js is a powerful library specifically designed for building interactive and responsive user interfaces. It helps you efficiently construct dynamic and engaging user interfaces for your web applications. Finally, Node.js is the JavaScript runtime environment. This environment allows you to execute JavaScript code outside of a web browser. Node.js is perfect for running your backend logic, ensuring high performance and scalability. Now, let us consider the various benefits of integrating the MERN stack for your projects. This integration enables a truly seamless experience for full-stack web application development. One major benefit is full-stack JavaScript development. This means you can develop both the front-end and back-end using just JavaScript. Another advantage is efficient data display. React.js efficiently fetches and displays data retrieved from your backend API. Lastly, consider the robust backend processing. Node.js handles data, user authentication, and interacts seamlessly with MongoDB. Let us begin by setting up the Node.js backend for a MERN application. This involves initializing your server and establishing a reliable connection to the database. Our first step is to create a new project. This command initializes a new Node.js project with its fundamental directory structure. Next, we need to install essential packages. We will add Express, Course, Mongoose, and .env for various backend functionalities. Then, we proceed to set up the server. This step configures Express.js and establishes the connection to your MongoDB database. It's crucial to configure your .env file. This file securely stores sensitive information like your database connection credentials. Finally, you will run the server. This action starts your Node.js backend application, making it ready to receive requests. Let's now configure our Express server, which is the core of our backend. We focus on the essential backend configuration steps within the server.js file. Here, we require necessary modules like .env, Express, Mongoose, and Course. Then, initialize our app. This code block imports all the required libraries and creates an instance of the Express application. We enable JSON parsing for incoming requests and configure Course for front-end communication. This sets up middleware to parse JSON bodies and enable cross-origin resource sharing. Next, we connect to MongoDB by utilizing the connection string stored in our environment variables. This code connects your application to MongoDB, logging success, or any connection errors. We define a basic API endpoint that will respond to GET requests. This creates a default GET route that sends a simple message indicating the backend is operational. Finally, we start the Express server, listening for incoming requests on a defined port. This code snippet launches the server, making it accessible on either port 5000 or a custom port. Now, let's move on to setting up the React frontend for our application. This involves initializing your user interface and preparing it for API communication. The first step is to create a new React application. This command quickly generates a new React project with its standard file structure. Next, you will need to install Axios. Axios is a library that enables your React app to make HTTP requests to the backend API. Then, we'll implement data fetching. This step involves writing code to make API calls and retrieve data from the backend. Finally, you can run your React application. This command starts the React development server, allowing you to view your application in the browser. Let's examine how to fetch data in your React frontend effectively. We will use the useState and useEffect hooks to retrieve data from our backend. First, we initialize the state and define side effects. The useState hook manages the message state, while useEffect handles side effects like data fetching after rendering. This code imports essential React hooks and Axios, then initializes a message state and an effect. Next, we'll make a GET request using Axios. Axios.get sends an HTTP GET request to the backend, then updates the message state upon success, catching any errors. This code snippet demonstrates how to fetch data from your backend and update the component state. Finally, we will display the message received from the backend. The fetched message from the backend is rendered in a paragraph tag, showcasing dynamic data display. This code renders the React frontend, displaying the message retrieved from the backend. Let's explore the common API communication methods used in web development. These methods are essential for performing CRUD operations between your frontend and backend. The GET method is used for data retrieval. It allows you to fetch data from the API, for example, a list of users. You would use GET to retrieve comprehensive user lists from your database. The POST method is for sending new data. This method enables you to send data to the API, like creating a new user. For instance, you would use POST to add new users to your system. Put or patch methods are for updating existing data. They allow you to update existing data in the API, such as modifying user details. You might use put or patch to edit specific user details in the database. The delete method is for data removal. This method lets you remove data from the API, like deleting a user record. For example, you would use delete to completely remove a user from the system. Let us now discuss various state management approaches available in React. These approaches are crucial for efficiently handling data flow within your React applications. First, useState is for local component state. It's ideal for managing state that is specific to a single component. Next, useContext provides global state. This hook is excellent for managing global state in smaller scale applications. Redux is for centralized state management. It offers a centralized store perfect for large applications with complex data needs. Recoil offers a simpler alternative. This library provides a more straightforward and often less verbose approach than Redux. Finally, Zustand is lightweight. It's known for its lightweight and minimal approach to state management. Let's learn how to implement secure user authentication using JWT. We'll focus on securing your MERN application effectively with JSON Web Tokens. First, we define a Mongo schema to structure our user data in the database. This code snippet defines the user schema with name, email, and password fields for MongoDB. Next, we create an authentication controller to handle user registration and login logic. This code demonstrates hashing passwords with bcrypt and generating a JWT for user sessions. Then, we define specific authentication routes for our API endpoints. This sets up express routes for user registration and login, linking them to controller functions. Finally, we integrate these authentication routes into our main Express server application. This code registers the authentication routes under the /auth path in your main server. To summarize, let's review the key aspects of MERN stack integration we've covered. These are the main takeaways for building robust full-stack applications with MERN. The MERN stack combines MongoDB, Express.js, React, and Node.js into one powerful framework. Your React frontend communicates with the Node.js backend primarily through Axios. Express.js manages API requests and facilitates database interactions with MongoDB. CORS is absolutely crucial for enabling smooth cross-origin communication between front-end and back-end. State management tools like useState, useContext, and Redux organize your user interface data effectively. For secure user authentication, JWT or JSON Web Tokens are commonly employed. A complete MERN application offers full CRUD functionality along with robust authentication mechanisms.